Okay, so we're starting to talk about section 6.7, and this is about special products. And remember that the word products means multiplication, so we're talking about special types of multiplication problems. We're going to look at this piece is really going to lead into what we're going to talk about and what we're going to learn when we start in our class Pre-College Algebra 2. So you'll definitely want to make sure that you are understanding this information before we move on. Our first example is going to be x plus 4 times x minus 4. All right, you're really going to hear this phrase or this topic, the special products. This one that you see on the screen is called difference of squares. Okay, you're going to learn about this in our factoring unit in Pre-College Algebra 2. Okay, special difference of squares tells you that you have the same number, x and x in the first place, and 4 and 4 in the last position, but one is positive and one is negative. One's a plus sign, one's a minus sign. When you have this format, the first ones both have to be x, the last ones both have to be 4, or matching numbers, and one is positive, plus sign, one's a minus sign. When you have that, you're going to take your first one and square it. You're going to take your second one and square it. And remember, this is difference of squares, and subtract, and this will be your final answer. Okay, it's a rule. It's called difference of squares. You get to square your first piece for your answer, square your second piece for the answer, and put a subtraction because it's a difference, so subtract. How did I get to use that? I have an x in the first position, x in the second one, a 4 in the last position, a 4 in the last. One was plus, one was minus, so I use that format. Here's what I want to show you. I want to do the same problem, and I want to think what happens if I did not know that this was a special rule. Well, nothing. I would go about my business and I would FOIL this, knowing that these are two terms, 1, 2, and 1, 2 multiplied together, right? No add or subtract between there. So I would multiply my first two terms, x, and I get x squared. My outer two terms would be x times a negative 4, which is negative 4x. My inside two terms are 4 times x, and I get 4x. My last two terms are 4 times a negative 4, which is a negative 16. These two are both x's. So I have a negative 4 plus 4, right? I have an x that I'm going to put in my final answer, bring it over. If I owe somebody $4 and I give them $4, I've got no dollars. 0x is no x's. So what do I have? X squared and a negative 16. I can get the same answer that I got here by knowing the special rule as I do here by just following FOIL. So is it helpful to save me all of this time to be able to remember the rule and just write it down? Sure. But can you do it without remembering it? Of course. All right, so let's look at this one. This is also a difference of squares. My first terms are both 3x. My last terms are both 5. One is a plus sign problem and one is a subtraction problem. So this is difference of squares. It fits. So for the rule, I take the first term and I square it. This squared belongs to every piece inside. So this becomes 9x squared. Minus, because remember it's a difference of squares. I squared my first piece, I have a difference, and then I'm going to take my second one and I'm going to square it, and I end up with 25. Can I do this problem without using the special rule? Yes. By FOILing. 3x times 3x gives me 9x squared. My outer two terms are 3x times a negative 5, which gives me negative 15x. My inner two terms are 5 times 3x, which gives me a positive 15x. My last two terms are 5 times a negative, 5 gives me negative 25. I have owe someone's $15 and I get $15, I've got 0 x, $0, which is nothing. Those canceled. So I have 9x squared minus 25. Got the same answer here that I did on the first page, just a lot less work. All right, so look at this problem. We're switching gears completely, okay? All right, we look at this problem and you immediately think to yourself that everything inside there is squared. So I'm going to give the 2 to the x and a 2 to the 4, right? The powers. The answer is no. If you had this problem, then what you see inside is separated by a multiply sign, and you're right, that 2 that's squared would go to both pieces inside. What makes this problem up here different is that add sign. It's an addition problem, which means that these two pieces are bound together and they go together. You cannot separate them like you can multiplication, okay? So let's look at this. When you do a problem like that you see at the top, the way that we solve it is to take everything inside twice. So this problem is actually solved by rewriting it to look like this. And now you have to FOIL. So F, O, I, and L. I know I have to FOIL because this is not a difference of squares. They are identical in their first term, both x's, last term, both 4's, but they are both a plus sign, okay? So because of that, we have to solve this a little bit differently. All right, so we are going to x times x gives me x squared. My outside two terms are x times 4, which is 4x, and 4 times x, which is also 4x. And my last two terms are 4 times 4, which is 16. These two are exactly the same. It gives me 8x. So I have x squared plus 8x plus 16. Okay, so this is not a difference of squares. This is actually what we call a perfect square because they both are squared. Okay, everything in there is squared and the middle terms do not cancel out. So you will break this apart into two pieces. How come? Because there is an add or subtract sign inside of it. That means that everything in the parentheses gets written twice. Okay, let's look at this one. That means everything in here, because there's an add sign, gets rewritten twice. You're going to FOIL. I've got 5 times 3x, which is 15x. Let's see. Oh, sorry, I wrote those wrong. It's still the same answer, but outside two terms are 3x times 5. The other one is 3. Good grief, 5 times 3x gives me 15x. And my last two terms are 5 times 5, which is 25. So these two are exactly the same. 15 plus 15 gives me 30x. So my final answer is 9x squared plus 30x. Plus 25. X squared, x to the first, and then a number. Those are in descending order, so that's kind of our standard form. Okay, let's look at one that's got a subtraction sign in it. Okay. It's still squared, right? There's a subtraction sign, so it means that everything inside is bound together, and you get to take 2 of them. Everything inside you get 2 of. So I'm going to FOIL. 2x times 2x is 4x squared. Outside two terms are x times a negative 3, which is a negative 6x. My inside two terms are negative 3 times a 2x, which also gives me negative 6x. And my last two terms are negative 3 times a negative 3, which gives me a positive 9. These two are exactly the same, so I've got a negative 6 minus 6, which is actually a negative 6 plus a negative 6. Signs are the same, add and keep the sign. So these become negative 12x. Think about them like money. I owe somebody $6, I owe somebody another $6, I owe $12. If you owe somebody, it's negative. So my final answer is 4x squared minus 12x plus 9. Final answer. Okay, they're going to kind of throw what we learned in the previous section into this one. So I'm going to do one problem that's a little more difficult. Okay, so I want you to look at the screen. This piece right here is what you see here. So everything we did on the previous screen, or in all the problems we've done up to this point, have been one part of this problem, okay? A subtraction problem is what we did in either 6.1, 6.2, or 6.3. We were subtracting polynomials. On this side is also something that we've done in this section in 6.7. So we're going to FOIL here because this piece is x plus 4 times x plus 4. This side is and I'm going to FOIL. Okay, my f on my left side, my first two terms are x times x, which is x squared. My outside two terms are x times 4, which is 4x. My inside two terms are 4 times x, which is 4x. 4 plus 4 is 8x. My last two terms are 4 times 4, which is 16. So this became x squared plus 8x plus 16 minus, and now I'm going to do the right side. X times x is x squared. Outside two terms are x times a negative 5, which is negative 5x. My inside two terms are negative 5 times x, which is also negative 5x. I owe somebody 5, I owe somebody 5, I owe somebody 10, so negative 10x. My last two terms are negative 5 times negative 5, which is a positive 25. So this became x squared minus 10x plus 25. Now we've got a problem like we've done in previous sections. It's a subtraction problem. When I distribute this negative 1 here to each piece inside, it's going to change every single sign. So this becomes a negative x squared and a plus 10x and a minus 25, and everything in front of it just comes down. So x squared plus 8x plus 16. So now we're looking at a problem where we are going to combine things that match or put together like terms, combining like terms. So I'm going to use this bottom space down here to make this happen. The first thing that I look at will be, let's see, the x's match, x squares, I'm sorry. The next thing that matches will be the x's. And then the last thing that matches will be just the numbers. Okay? And so with that in mind, we're going to work through the rest of this problem. So if I put together a positive x squared and a negative x squared, well, this is understood to be 1, and this is also understood to be a negative 1. So if I have 1 plus a negative 1, I have 0x squared. 0x squared is nothing. They cancel each other out. So we are done with these two pieces. The next part that I bring down is going to be a plus 8x and a plus 10x. They're both x's, so I'm going to put my x on my answer, and I have 8 plus 10. 8 plus 10 is 18x. So 18x is going to be a part of my answer, so I'm going to kind of box it so I know what I have. If I move on and I look at the blue parts, I have plus 16 minus 25, which is actually 16 plus a negative 25. Signs are different. I'm going to subtract and take the sign of the bigger number. So my bigger number was 25, which is going to be negative, and 16 minus 25 is 9. So the two pieces that I have remaining for my final answer is going to be 18x minus 9. Final answer. How do I know that 18x goes first? Because I'm looking for the highest variable down to the lowest variable. All right, that's all we have for section 6.7.